Good morning, everyone. My name is Ben Sroor. I'm a program manager on the Windows User Experience team. I've been a program manager for about 7 years now, and my team is responsible for the process lifetime management component of the Windows 8 shell. Today, we're going to talk about fundamentals of Metro-style apps, how and when your app will run. First, we're going to talk about the new lifetime model that we have. Then we'll transition to how your application can be instantiated in Windows 8. Then, since you've probably heard this already, that apps don't always run in the system, we'll talk about some tips and tricks for making your app always look like it's running, even though it's not, using saving and restoring state techniques and using live tiles. And lastly, we'll wrap up with a quick discussion of additional ways to make your app always look like it's, or some additional ways of making your app run. So today you'll leave with some specific examples of how to make your app always look alive, and you'll be fully versed in the new lifetime model that we have. I'll be down here with my team after the session to help answer any questions that you have. So let's take a look at Windows 7. In Windows 7, the model was you would launch applications, and the user would be responsible for managing the lifetime. Users would close applications when they were done with them, or they would close apps when they wanted better battery life or better system performance. In Windows 8, we have a different model. We say we're going to focus on the foreground app. That's the most important app in the system. Then we take apps that are in the background and we pause them so they have no impact on system performance. So the system manages what applications get to run, not the user. Let's walk through what this actually looks like. So I've got app 1 that's running full screen, and then I launch app 2. After a short delay, app 1 immediately goes to the background, and after a short delay, the application will get a suspending message. That suspending message is the last indication to the application that it can run any code. This is an opportunity for the app to save state and essentially prepare for termination, because it's the last opportunity it gets to run any code. The user can launch other applications, app 3 in this case, and then app 2 also, based off of policy, goes off screen and eventually will get suspended. And so on as the user launches subsequent applications. Now, let's say I'm playing a game, and that game requires a lot of memory. Well, what the system will do is it will notice that the system might be getting into a low memory condition, and then will terminate applications that are suspended. Now, this looks like it's a first-in, first-out model. It's not. We target applications that are the biggest memory offenders. So the important thing to note about this is that applications transition from the running state to the suspended state, where they get a notification, but then when apps get terminated by the system, there's no notification. So they just get deleted from memory. One of the benefits of the suspend model is that users can instantly switch between suspended apps and to make them running. So we call that fast app switching. And you can see here if the user switches to the second app, because the app was already in memory, meaning the threads were there, the stack is there, the heap is there, the app can be instantly resumed and pick up right where it left off. And that's known as resuming. So we have a new process state called suspend, and this allows us to focus on the foreground app. There's no reason to allow system resources to be deteriorated for apps that the user is not getting value from. So we focus on the foreground app, and then apps that are in the background get suspended by the operating system. And this has the added benefit of enabling really fast, instantly fast switching. Just like the saying goes, termination happens, and apps, I'm not very funny, so it was 50-50 or lower that I was going to nail that joke. But apps get terminated in the system, as I mentioned, when they're suspended. And that can happen in various cases. One is low memory. The other is the app taking or the user switching between user accounts, or the user rebooting their machine. And then, of course, app crash. We'll talk about app crash later. When an app crashes, it does not get suspended first. It just goes away. So just underscoring here, when an app gets suspended, that's the last opportunity to run code, so you always have to prepare for termination. Let's walk through what this looks like. OK, so we've got our Windows 8 device here, and I've got the beautiful new Task Manager with a status column and CPU and memory shown. And what we're going to do is bring up a app, which is the Weather app. Now, the Weather app is a beautiful full-screen app that I really like to use to check the weather. One of the benefits of the Weather app, and the reason it looks so great, is that it's playing a video. It just also happens to be a huge CPU hog, because it's playing a video, and playing a video is not free. So that's taking up, what, 10%, 9% of my CPU right now. Now, if I put this app to the background, in a world without lifetime management, this would have a negative impact on performance and battery life. I don't want this app rendering video if I can't see it, right? So what we do is we suspend the app. Let's put the app to the background. And after a short delay, you'll see that the app will get suspended. The app got suspended. And then you can see the CPU column indicating the 10% CPU is now 0. So the app got the suspending message. The app had a chance to clean itself up, and then it got suspended. And now it's taking up no resources in the system. But I can now switch back to the app instantaneously, and that was resume. And so in Task Manager, you can see the app went from suspended back to running, and that was instantaneous. Why was it instantaneous? Because the app was already in memory. The only thing we had to do was tell the scheduler, hey, start running these threads again, and the app started to run. Now, let's show what termination looks like. So we're going to suspend the app. Now let's pretend that I've launched lots of apps. I've gone on my day, and I've been using this device for hours and hours and hours, and I started to use applications that need a lot of memory. So I've got a little command line tool here that I call usemem, and I use this to simulate termination. This is going to simulate a low memory condition. So right now we're allocating 2.1 gigs of RAM, and what you saw was the Weather app is no longer visible. The Weather app got terminated. Now this was a clean termination. The app, this is the normal part of the life cycle. We just simulated a low memory condition, but the app was cleanly terminated by the system. So let's recap what we just talked about. So we launched the Weather app, and then we saw a splash screen. The app came up, and the green here represents code is running. Then we switched away from the Weather app. After a short delay, the app got the suspending message. When the app got the suspending message, it had 5 seconds to deal with that event. If it took longer than 5 seconds, we're going to crash that app. Then the app got suspended. Then we switched back to the app, and then the app was running again. And at that point, the app could have subscribed to the resuming event, which indicated that the app was coming back from suspend. Then we simulated a low memory condition, which caused the app to get terminated. As I mentioned, there's several ways for an app to get terminated. Low memory is one of them, but user switch is another one, system shutdown as well. But in that case, no code was running. When the app was suspended, the code was in memory, but it wasn't executing. And of course, when the app is foreground, it's running. Registering for suspend and resume is quite easy. You simply have to add an event listener for the suspending callback, and then provide a event handler for that. So here we register for suspending and provide a callback called suspending handler, and the suspending handler function gets called back when that app goes off screen. This is an opportunity for the app to save any state and prepare for termination, because the app may not get a chance to run code again. The reality is that the Windows ecosystem is vast, and there are some machines that have tons of memory, and there are some machines that have very little memory. So for building really great applications, Metro-style apps, you really want to make sure that you work on that wide range of devices. So in some cases, your apps will get terminated really frequently. Then you can also register for resuming in this very similar way as suspend. You add an event listener for that. You basically say, add event listener for resuming, and provide a callback. Now, the resuming handler function is defined there. In general, though, most apps won't need to use a resuming handler because the app is already in memory. The threads are there, the stack is there, the heap is there. So the app will be brought back instantaneously, just like the weather app. But let's say that you've got a list view, and that list view is data bound to a web service. And the web service may expose data that has changed since the last time the user used the application. Resuming is a great opportunity to just go and refresh that view, requery that data source to provide the most up-to-date view in your application. I showed this examples in JavaScript, but doing this in XAML or C++ is very, very similar. So let's dive a little bit more into suspend. So kind of suspend under the hood. When an app is suspended, it's just literally not scheduled by the NT kernel. So the app stays in memory, but the instructions inside the process are just not being executed. So it has no impact on the CPU, no impact on disk or network. It's kind of like in Visual Studio when you're debugging an application and you hit the pause button. When you hit the pause button, all the threads are there, the app is in memory, but they're all just not running. And then you can, resume it, and that continues execution of the app. And the benefit of this model is that since the app is in memory, we can switch back to apps instantaneously. One of the awesome things the kernel team did here was do some optimizations to ensure that when the application got suspended, we don't ever suspend in a critical section of the code. So we make sure that when an app is suspended, it will not cause system-wide instability or deadlocks. So now you're familiar with the lifetime model, but let's talk a little bit about the beginning of the life cycle. What happens when you launch an application? Well, when we were planning Windows 8, we saw an evolution of user desires. And Jensen talked a lot about this yesterday. But we have the information snacking scenario, where users like to get a lot of information very quickly, which was one of the motivators behind Tiles. Then there's the sharing scenario, where apps like to share, or users like to share between applications, which helped motivate making sharing a first-class construct in the system. And of course, searching is incredibly popular, and performing in-context searches as a first-class citizen was very important for us as well. Which is altogether different than how users launched applications in Windows 7. In Windows 7, obviously, users would just double-click on icons, and then the app would come up. In Windows 8, applications are activated as a result of contracts. There's many contracts in the system. I believe there's over 10. Great applications integrate with many contracts. We're going to talk about the launch contract today, the search contract, and the share contract. When an application is activated as a result of a contract, the most important thing to do is fulfill the contract. So if your application is activated for search, well, you should take the user, you should figure out, when your app is running, figure out that it was a search activation by inspecting this property called kind, figure out that it was a search activation, and then navigate the user to the search experience of your UI, take the context that's provided by the activation, and then perform the search. Like, you can tell a very similar story for share as well. Perform the share, initialize the share, etc. When an application is activated, it gets, at least in JavaScript and HTML, it gets a activated callback. And when this callback occurs, you can inspect several things about the activation, like the kind property, which will tell you how the app was activated. The activated event also has some other kind of neat attributes as well, which we'll get into later. And in XAML and C++, there's a different model for activation. I believe in XAML, there's a specific function that gets called back for the various contracts. So there'll be like an onSearched function that gets called. There'll be an onLaunched function or an onShare. So it's slightly different from language to language, but the concept is the same, and we call that activation. So let's walk through some examples of application activation. Okay, let's free up some of that memory. Okay, so the first thing we're going to do is pull up the Charms bar. We're going to search. And let's type in Windows 8 and use Tweetorama to search for it. The first thing you saw was a splash screen, which we'll talk about in a second. And then the search view of the Tweetorama app came up immediately. So the Tweetorama app found out that it was an activation, that it was a search activation, that there was context provided, and it navigated the user to the search screen. It made that the first screen to show to the user, and then it performed the search. Now let's talk about the share activation. We'll go into the Socialite application. We'll go to Photos. We'll pick a random album. We'll go here, and we'll go to Share, and we'll share this to Tweetorama. And here, what we saw was, oh, it's because I'm not logged in on this one. Let's go here. Okay, so what you saw here is the Tweetorama app was activated in this flyout window, and this enabled communication between these two applications. And so context was passed between these two apps. And in this case, it was a URI of the location of this photo. So splash screens. By now you've seen them. Splash screens are a consistent introduction to your application. They're shown while the application is launching. It's when Windows is launching your application. So for a brief moment in time, the splash screen will be shown by Windows and totally owned by Windows. That's probably a couple of milliseconds. But for the most part, while a splash screen is being shown, that's when your application is handling activation. A splash screen consists of two elements, a logo and a color, both of which are specified in the application manifest. You can go into Visual Studio and select from that list view that's on the right side, or the tree view rather, and that will bring up the application manifest editor, a nice UI on top of that manifest. And then you can just specify a color and the logo. And then those two will be picked when your application is activated. We don't want users to wait a long time when applications are launching. So if your application doesn't complete activation within 15 seconds, we will crash your app. It will look like a crash to the user. Now, you might be thinking to yourself, well, wait a minute, I need a little bit longer to load. A good example of needing longer to load would be querying a data source. So let's say you've got a web service that you need to poll or check when you launch your application. And that I/O could be non-deterministic in length. It could take longer than 15 seconds because you might be on a 3G network. Well, in that case, we recommend using an extended splash screen. An extended splash screen basically is a splash screen, but it's the first view of your app. So you can call the splash screen API to figure out where the logo should be placed and what color to use. And then you can have a seamless transition from the system-provided splash screen into your extended splash screen. A good example of an app that does that is the weather app. As you can see, it has a progress indicator with text and an animation that is not system-controlled, it's app-controlled. But because it used the extended splash screen, it was able to do that. And there was a seamless transition because it used these splash screen APIs. So we recommend you look at the Splash Screen SDK for some more information about that. So now let's tie this all together. So we'll walk through launching an application through tiles. So tapping on the Tweetorama tile. When this happens, the kind property gets set to launch, indicating that it was a tile launch activation. Then, when the activated code is now running for the app, the activated callback occurs. There are some event args that get passed in, and that's where you can inspect what sort of activation it was. So while this callback is happening, the splash screen is being shown, and you can initialize your application and fulfill the contract specified. One thing I forgot to mention on a previous slide is that in JavaScript and HTML, the splash screen goes away when you're done handling activation. So all you have to do is just return from that callback. If you're building a XAML app or a C++ app, you have to present a window. And there's an explicit call to present a window, and that signals the end of activation. And that red marker there indicates that activation has been completed by presenting a window or completing the activated callback, and then the app is running. Registering for activation is simple. You simply have to add an event listener for the activated event and provide a callback. And we've talked about the activated event args before, earlier, and one of the properties to inspect is the kind property. The kind property can be examined to figure out what sort of activation it was. So in the first if statement here, we're checking to see, was this a launch activation? If this is a launch activation, I'm going to do one thing. But if it's a share activation, I want to do something else. So that's what the else if in the second block does. There's some other interesting properties on the event args as well. One is a property that we call previous execution state. And this will tell your application that it crashed the last time the user tried to use it. I'll talk about that in a couple of minutes. So by now, we've talked about the new lifetime model, and we've talked about the start of the life cycle, launching applications. But since applications don't always get to run in Windows 8, let's talk about some tips for making apps always look like they're running. And that's just to say that polished apps in Windows 8 always look like they're running, even if they're not. So as I mentioned, there's a broad ecosystem of devices, some with not a lot of memory. So termination is going to be more frequent on some devices. So you've always got to provide a consistent experience for your users. The first thing we suggest is to incrementally save user data. Don't wait until the user is leaving your application to save user data. Save the data while the user is using your application. On the left, we have an example of the NoteSpace application where before build, I was prepping and taking notes. And even though I had to switch and go do other things, the data was always there whenever I would come back to it, even though the application got terminated. But imagine a world where it was getting lost. My to-do list was gone. That would be pretty annoying, and it would be really frustrating for your users as well. So definitely, and this is a mind shift change, so definitely make sure or try to re-engineer your app so that you can save incrementally. Great apps always save and restore state. Saving application data is very important as well. And John Sheehan is going to talk a little bit more about this in his session. He's got a whole talk on it. But application data is your settings. So if you've got, like in the Twitterama app, you've got the username and password that's used and the authentication token that gets generated. You can save that to application data, and that will roam with the application. So if users have a connected account, they can log in through various devices, and that settings will be there. As Jensen mentioned yesterday, users shouldn't have to flip the toggle more than once for an application. So leverage the windows.storage.application data for this functionality. Now, of course, all of this is just a wrapper around File.io. So you can definitely use File.io as well, but it won't necessarily get you the roaming benefits. We like to disambiguate also session state. Session state is where the user is in your application at any given time. So if they've partially filled out a text box, if they've checked a checkbox, but if they're like 4 screens into a wizard, that constitutes a session. So when the app is getting suspended, you want to checkpoint where they are in that flow so that you can bring them back. There's a couple ways of doing this. Of course, you can use File.io for this. We have a nice object in the Win.js toolkit called session state. And the nice thing about this is it's just a JavaScript object, so you can put keys and values in there, and it'll automatically get serialized when your application gets suspended. When your application gets reactivated that JavaScript object will get automatically rehydrated. And it's smart enough to not rehydrate the data if your application crashed. There's a class that we have in XAML and C++ that you can use called Suspension Manager that basically does the same thing.
Can you put rich objects in there, not just text?
You can serialize any kind of object in there. It's like a JavaScript object. Yeah. So we've talked about crash, or I've mentioned crash. Applications can crash in various reasons in Windows 8, and we know that users don't like hung apps. They don't like apps that are inconsistent, so you obviously got to fix your bugs. But apps can crash for any number of reasons in Windows 8. One is if they take too long to load. So we mentioned 15 seconds to show a window. Make sure that you finish activation quickly, and if you're going to take longer than 15 seconds, use that extended splash screen so you don't get into this state. If you take longer than 5 seconds to suspend, your app will get terminated, and it'll look like a crash to the user. And of course, if you do, which is a big no-no, if you do blocking I/O on the UI thread and block the message pump, your UI is going to get crashed by the system. And of course, the user can always go to your application and terminate it through Task Manager as well, which will look like a crash to the user. When this happens, bring the user back home. And you can detect that by looking at this property called previous execution state, which is a variable that's exposed on the event args in activation. So just to summarize some of the best practices here, when the user is using your application, save data incrementally. When the user switches away from your application and you're getting the suspended callback, save where the user is. Save where they are in their session. You can use session state, you can use file I/O, but just save where they're at. When your application gets activated, bring them back to where they were when the application was last used. So it makes it look like the user never left. And then if the application is getting resumed from a suspended state, in general, you don't have to do anything, which is great. But you might want to refresh that data view, for example, and that would be a good reason to subscribe to that resuming event. So now let's roll up our sleeves a bit and add state savings to an application. Cool. All right. So let's first take a look at, we're going to do this on the Twitterama application. So I've got the Twitterama app. And so this is my test version of it. So I have to re-log in. So the Twitterama app comes up, and I can use the application. I can go pan left. I can pan right. I can fill out a tweet. Demoing at build. Really funny. Uh-oh. That wasn't in the prep. So I won't tell if you don't tell. So let's say I'm halfway through using the application, and then all of a sudden I get called in to do something. I have to go check my mail, or I go use another application. Well, I'm going to go do this. I'm going to go switch to some other apps, and let's kill that. That's the other Twitterama app. That wasn't the app we were just using. So after a second, the Twitterama app we were just using is going to get suspended. Let's try that one more time. Let me just restart Explorer real quick. going to go back to Tweetorama, and now I'm going to switch away, and the Tweetorama app should get suspended. If it doesn't, then that the demo gods are not with me. OK, it gets suspended. OK. Recovering on the fly. OK, so the app gets suspended, and now let's cause a low memory condition, just like we saw before. Tweetorama app is going to get terminated. It's gone. And now you guys know what's next. It's the application. I go back to the app, and that hilarious tweet that I partially wrote is gone. And where I was in the app is gone. So I'm starting over. And as I mentioned, this is a pretty incongruent experience for users. This is really inconsistent, and it does not look polished at all. Really great apps should always bring the user back to where they left off. So let's add state savings to this application. It should be pretty easy. OK, so first thing we'll do is let's get this out of memory. And then let's uninstall it. So I've got the source code for it up here. And OK, so the first thing we're going to do is register for suspend. So we're just going to add the event listener for suspending. Just drag it over here. And that's just like the code I showed a couple slides ago, where we provide a callback for suspending handler. And suspending handler is going to get called when the app gets suspended. So let's drag over this function called suspending handler. And I do one thing in it, which is called save state. Let's quickly define a function called save state. This is a little bit more complicated. We're going to create a new JavaScript object, and we're going to retrieve the scroll left property from the main grid element of my page. And that's the number of pixels over I've scrolled over. Let's store that to this JavaScript object, and let's call it current scroll position. Then we're going to take the value of the current text box, that partially written tweet. We're going to take the value of that and store that also into this JavaScript object. And then, in that last line there, we're going to write this out to a file. But first, we're going to call json.stringify to serialize that the JavaScript object to a string, and then write that out to disk. This is basically what session state does, that WinJS session state object does. So we recommend you use that. Just wanted to show you what it looks like under the covers here. So now let's write a function called loadState. And this is what we're going to call when our application is initializing. So we create another state object here, which creates a new JavaScript object. Then we're going to read in from this underscore session.json file. And then in the async callback for the read text API, we're going to reconstitute. We're going to take from a string, which we've just read in from disk. We're going to turn that into a JavaScript object and assign it to the state object. We're going to check to see if current scroll position is null or not. If it's not null, we're going to update the main grid elements scroll left property so that we can figure out where we were, and then check to see if there was a tweet in progress in that object. And then if that's not null, then we're going to update the text box value with that property value. And now let's make sure we call the load state function, and we're just going to call it here in our initialization code. Oops. We're building. Let's deploy. OK, now let's go back to Tweetorama. So because we uninstalled it and redeployed it, all the data was gone, so I have to re-log in. So I'm logging back in, and let's say we've got a partially written tweet here. And I scroll halfway through, and now put the app into the background like we showed, and the Tweetorama app will get suspended. The app gets suspended. Let's simulate a low memory condition. The app gets terminated by the lifetime manager. And now we're going to go back to the application. Relaunches, and we're brought back right to where we left off. And the text box is partially filled in. So as you can see, that's a lot better of an experience for users than just dropping them back in as if they weren't using the application at all. Cool. So we've talked about state savings. Now let's talk about another way of making your app always look alive, and that's using live tiles. Live tiles are an opportunity to provide value to users even though they're not using your application. They give the user a sense that there's something going on with your application, even though they might not be using it. The way that tiles work is through notifications. A tile update consists of a small snippet of XML that follows a template. What you see on the screen are 3 different templates. These templates basically have a couple of image references and strings. So inside that snippet of XML, you say, well, I want template 1. And template 1 has 2 strings in it and 1 image. The image that you reference could be a cloud image, an image that we have to get over the internet, or it could be an image that's local to your package. There's 2 mechanisms of updating tiles. The first is updating them locally. This is called local notifications. This is great for applications that don't have cloud services or are just kind of local only. So if you've got a game, you could potentially save the last score. Or if you've downloaded some pictures from an application and you want to show the last activity that a user did, like they panned through 4 or 5 photos, just show that activity on your tile to reflect the last action the user took. Or if it's an ebook, reflect the current paragraph that the user's reading or the chapter heading. The important thing to note here is that this can only be done while the code is running, while your code is running. So you could do this while your application is getting used, or you could call it when your application is getting suspended. But what if your app is not running? Well, if your app's not running, we have push notifications. Push notifications are a great way to update your tile and give the user a sense that there's something going on with your application, even though the user's not using your app, and your app might not be running at all. It's great for showing the newest content available to users. The way this works is when you launch your application, you can call the notification APIs to receive what's called a channel. A channel is a unique identifier pointing to your user's device and account. You take that channel, which is basically just a long URL, you take that channel, you send it up to your cloud service. You associate it with the user that's authenticated with the application, and then you store that. And whenever you have new data that you want to share with the user, you just do an HTTP post to that URI with the same tile XML that I talked about a minute ago. The message will get routed to the Windows Notification Service, Windows Push Notification Service, also known as WNS. The notification will then get delivered on the user's start screen, and it'll look fresh, even though your app wasn't running. And it was your cloud service that drove the update to the tile. There's a lot here, so we don't have time to get into this, but there is a dedicated talk on this called Using Tiles and Notifications. I know Jensen referenced it, and Kip's going to do a great job telling you guys all about it. So we've talked about the lifetime model. We've talked about the beginning of the lifetime, when applications are launched. And we've just talked about some additional ways, or some ways that apps can always look alive. Now let's talk about some additional ways that apps can run in the background. The first is through background media. We understand that there are some apps where they need to play music in the background for the user to continue getting value from it. And there's a background audio exemption. The way you do this, the way you work with this, is in your manifest, you specify in the background tasks section, you specify the background audio enumeration. Then all you have to do is call the audio APIs, specify the sort of stream type, the sort of audio that's being played, and your app can play audio in the background. There's a limit to how many of these can be going on at once, and I believe it's 3 depending on the stream type. And if you want some more information about this, Johnny is talking about this, I believe, on Friday, and it's Media Fundamentals of a Communications App. You may also need to do an upload or a download in the background. And the way you can do that is by using the Background Transfer API. The Background Transfer API allows you to initiate a upload or download over HTTP, which will continue even though your app may be suspended. So it doesn't let your app run. It just keeps, while your app is suspended, the upload or download is occurring. Then when the user switches back to your application, the download, if it was a download, will be there. If you want more information about this, there's a session called Making Apps Social and Connected with HTTP Services. I recommend you go there, and Suhail's going to do a great job on that. And lastly, we have lock screen apps. Lock screen apps are apps that need to be able to notify you even though you're not using the device. These apps are allowed a little bit more of a liberal mechanism to run in the background. They're designed for real-time communication apps, your mail apps, your IM apps, and your VoIP apps. One of the affordances that lock screen apps gets are the ability to maintain TCP sockets in the background. The canonical example for that would be maintaining a socket connection to an Exchange server, or maintaining a socket connection to an IM service. You also have the ability to run code periodically, so you can run code in the background every 15 minutes, and this is designed for mail applications. So you could pull a POP3 mail service every 15 minutes to check for mail. So you perform the POP3 mail check, and then you update the badge that shows up on the lock screen, or you pop a toast notification to indicate that there's new mail. This is also the only system affordance that allows you to run code when the user logs into Windows. So this can be used for logging into an IM service, for example, or making sure that the user has the most up-to-date unread mail count when they log in. There's a dedicated session on this that Raghu and Kamal are going to talk about on Friday, and I reference it in the last slide here. So let's recap everything we've talked about. So activation best practices. The most important thing here is activate quickly. You only have 15 seconds, so bring the user back to where they left off, and if you need longer than 15 seconds, use an extended splash screen. When your application is suspending, make sure that you save state. Don't wait until suspend to save your user data. You only have 5 seconds. So if you have some data file, some sort of proprietary data structures that you need to serialize to disk, that's going to take longer than 5 seconds. So you cannot do that, or we don't recommend you do that in suspend, because your app only has 5 seconds. So losing user data is bad. Save user data while the user is using your application. Also, update your app's tile while it's getting used, and make sure that you're always incrementally saving state. But suspending is a great opportunity to checkpoint session state, checkpointing where the user was in their flow before the app gets frozen, because it's the last opportunity to run code before the app gets terminated. So let's recap everything we talked about. So we have a new philosophy on process lifetime in Windows 8. Apps that are in the background get suspended and eventually terminated. And there are some best practices for making your app always look alive and fresh by saving and resuming state and using live tiles. So we have some related sessions here for you to look at. And my team and I will be down here to answer any questions that you have. And I hope you guys enjoy the rest of the conference.